Good morning, everyone. Today I'll be introducing you people to our new subject with, with the title as Signals and System. This is one of the core subject in fourth semester with the subject code as 18EC 45. Uh, it's a basic subject which an EC student should know because this is the foundation for most of the subjects like signal processing and communication systems. So in today's session, I'll just give a brief introduction about the subject, prerequisites of the subject along with the basic concepts will be taught. Coming to the syllabus, the total marks allotted for this subject is 100 marks, among which 40 marks is considered as CIE marks for internals and semester end examination marks is for 60. Exam hours is 3 and the credit points is 3 for this particular subject. So here in the syllabus there are 5 modules which gives a brief introduction about the subject. Then we will learn about the important properties of the system, followed by Fourier representation and set transform representation of the system and signals. In first module, a basic introduction to signals and system is given along with classification and basic operations. In this module, we will discuss about definition of signals and systems, communication and control systems as examples, along with classification of signals into different categories based on characteristics. So in the classification, we will discuss about continuous and discrete time signals, analog and digital signals, followed by even and odd signals, deterministic and random signals, periodic and non-periodic signals, energy and power signals. So this is the first basic classification what we have for signals. And then we will discuss about elementary signals and functions, wherein standard signals format will be taught, which includes impulse function, step function, sinusoidal function, exponential function and ramp functions. Along with that, you will learn about expressions of different types of signals like triangular, rectangular and other waveforms will be taught. And then along with this, basic operations of signals, where you will learn about operations performed on dependent variable amplitude and operation performed on the independent variable time. So here the basic operation performed on the independent variable is considered as time scaling, time shift and time reversal. So these are the basic operations that can be performed on the independent variable time. So in amplitude operations, you will learn about amplitude scaling, addition, multiplication, differentiation and integration. So this is a brief introduction to the first module. So in second module, we will discuss about system classification and their properties. So here basic properties of the systems like linearity and non-linearity, time variance and invariance, causality and non-causality, static and dynamic properties, stability property and invertibility property of the system will be learnt. So based on these properties, the system is classified as linear time invariant system. So this is one of the important topic from the examination point of view, and these basic concept what is learnt in the second module is applicable for the digital signal processing subject also. So an extra attention should be paid for this particular topic, that is time domain representation of LTI system, wherein we will discuss about impulse response, convolution operation for discrete and continuous time systems, which is evaluated using convolution sum and convolution integral. And we will discuss about computation of convolution sum and integral using different methods, which incorporates graphical method, formula method, for a variety of combination of signals, which includes unit step, exponential and rectangular pulses. This is about second module. In third module, we will discuss about properties of the particular system, which is an LTI system. So here we will learn about system interconnection and the properties of LTI system like memory property, causality, stability, invertibility and deconvolution will be discussed along with step response of the LTI system. In the frequency representation of periodic signals, we will take up an important Fourier series representation, that is continuous time Fourier series representation, and properties of this will be discussed along with the basic problems. In fourth module, you will learn about Fourier representation of aperiodic signals, where we will discuss about two important type of transformation, that is Fourier transform on discrete time Fourier transform. Definition of these two transforms along with few basic problems will be discussed. Then we will take up the properties of Fourier transform both in discrete and continuous form, where we will discuss about the important properties like linearity, time shift, frequency shift, scaling, differentiation and integration, along with convolution and modulation. So one important theorem which is discussed here is Parseval's theorem, which is used to find the energy level of a signal. And important problems on all these properties will be solved in fourth module. So Fourier representation of the signal is also a basic concept which you will further learn in digital signal processing and communication systems. So you are supposed to pay concentration on this particular topic also. In module 5, we will learn the application of Z transform for analysis of signals and systems. So here basic definition of Z transform will be taught along with properties of region of convergence and properties of Z transform. So along with that, we will discuss about inverse Z transform, causality and stability property of LTI system. Then you will learn about analysis of LTI system using the Z transform, which is termed as transform analysis. So this is the brief overview of the syllabus, which is including 5 different modules. These are the textbook which you need to refer for the above syllabus. The syllabus is framed according to the textbook Signals and Systems by Simon Higgins and Barry Van Veen. It's a second edition book. So this is a very good book for signals and systems, which you can refer as your textbook. So along with this, there are other few books which is listed as reference book, under which you can refer Fundamentals of Signals and Systems by Michael Roberts, second edition, and then Signals and System by Alan V. Oppenheim, second edition, Signals and Systems by R. Rajan, Linear Systems and Signals by B.P. Lati, and Signals and Systems by Ganesha. So these are the books which you can refer for the above syllabus. Now coming to course outcomes, once this subject you study, what is that you are going to gain, or the knowledge you are going to gain out of this subject is classified into 5 different course outcomes, which is named as CO1, CO2, 3, 4 and 5. So this subject makes you to understand and analyze the different types of signals and systems, and you can determine the various properties of continuous and discrete time system, and along with this prerequisite knowledge you can of LTI systems, you will be able to compute the response of continuous and discrete time LTI systems using convolution. And using Fourier series analysis, you can determine the spectral characteristics of continuous and discrete time systems. And finally, you will be able to apply the knowledge of Z transform to analyze the discrete time systems in the frequency domain. So this is the course outcome of the subject, or the knowledge. It indicates the knowledge what you can gain at the end of this particular course. Let's start with the first module. So as discussed in the syllabus, here the content of this modules are, initially we will discuss about definition of signals and system, communication and control system examples, classification of signals, and basic elementary signals, followed by basic operations on signals. So let's start with the introduction. Initially, let's discuss about what is a signal and what is a system, why it is important. So simply as the name indicates, signal is considered as a function of one or more variable that conveys information on the nature of the physical phenomena. So technically speaking, signal is anything which conveys a information. So for example, if I can quote, an ECG signal which is generated from a heart gives the information about the working condition of an heart. So any such function which gives us a valid information regarding the nature of the phenomena is considered to be a signal. So similarly, we have a number of signals surrounding us which is giving us one or the other kind of information. So our human body itself generates a lot number of signals. For example, if I consider my brain, so brain is considered to be the controller of the human body system, and I can consider my entire body to be a system which is working with the signals that is generated from the different parts of the body. Okay, so if any one of the system part fails, then your body is not going to respond in a proper way, is it not? So we are supposed to, proper information should be given to all the organs of the body if the system has to function in a proper way. So just remember the keyword that signal is what, when you get an idea of a signal, just have a keyword that it gives you a information. Now coming to system, and it's considered as an entity that manipulates one or more signals to accomplish a function, thereby yielding a new signal. So here a simple block diagram of a system is shown, where I'll have an input signal, okay, and an output signal. So why system is required is, see, I have some kind of information and it has to be transmitted somewhere, or I have a signal, if I want to modify the signal according to my requirement, then I need a media, okay, where a modification on these signals will be done to generate a new signal which can be used according to the requirement. For that purpose, we require a system which is a media which transforms the signal to another form, or it modifies or manipulates one or more signals for a particular function of operation. Okay, so in a system I can have a number of elements which is interconnected together to perform a particular operation by receiving an input signal. Okay, so this is a simple definition of a system. So a simple example, as we have considered, human body itself can be considered as a system where you have a number of organs which are working together, and they are receiving the input signal from the controller brain, and according to that the corresponding operation is done, which is considered to be the output. And in the electrical form, if I can quote one example, I can consider an example of an amplifier. So amplifier is a device which amplifies or increases the amplitude of a signal. So here, once the input is given, the amplitude of an input signal is multiplied with the gain factor, and a new signal will be generated with an increase in the amplitude. So like this, we can modify any signal, or we can extract the information content from a signal using a system. So when we consider the system, we need to have two important keywords which we need to remember to analyze the operation of a system. One is system analysis and another one is system synthesis. So system analysis means analyzing the output of a signal when the input signal is given to the system. Okay. System synthesis means designing the system when the input and the output signal is given. So this is what you will learn in further subjects. Okay, so systems can be classified based on their behavior and based on their properties, which we will learn in the further coming classes. Now this is about the basic definition of signals and systems. So another definition for signals which you can write is, signals can also be considered as a function of independent variable that carry information. So few examples of signals are listed here. So all your electrical signals like your current and voltages in a circuit can be considered as a signal. Your acoustic signals, that is audio and speech signals, are considered to be a category of signals which is available in nature as it is. Video signals and biological signals like ECG, EEG also come under this category. Now one important thing what we have to know when we define any of the signals is, signal is always measured with respect to time, and time is considered to be the most important independent variable which is used to define a signal. Okay, so whatever example you take, time is the predominant variable which measures the amplitude of a signal with respect to its variations. So any signal for that matter, if we take, always the x-axis is occupied by time and the y-axis is occupied by the amplitude in the time domain representation of any of the signals. So we are going to define the signals using the time domain representation with the independent variable time. Now based on the independent variable time, the signals are classified as continuous time and discrete time signals. So which is also termed as CT signals and DT signals, discrete time signals and continuous time signals. Most of the signals which is physically available in the world are considered to be continuous time signals. For example, if you take the biological signal, that is ECG, EEG signal, voltage, current, pressure, temperature, velocity, acceleration, all these things are considered to be continuous time signals, because all these signals are defined continuously with respect to the time t. So one thing what we need to remember here is, all the continuous time signals are represented using the independent variable time t. So when we define any of the continuous time signals here, please note this here. So this is my continuous time signal x of t. So this continuous time signal x of t is represented with the independent variable t. We can use any alphabet from A to Z here to define the variable, and within a round parenthesis we need to mention the independent variable which we are considering. So since this is a continuous time signal which is defined for all the instant of time here, I am defining it as x of t. So generally in signals and system subject, x is considered to, for most of the input signals, and y is considered as the variable for the output signals in our representation. So now coming to discrete time signals. So discrete time signals are represented using the independent variable n here, when n is considered to be the number of samples which is an integer. So this is the time which is varied discretely. That is, we will not be measuring the value of the signal continuously. So at some discrete instance of time, the signal values are measured. So as you can see in the diagram here, okay, so variable here is n, independent variable, and the dependent variable is x here. Now here, as we can see, we have a value of a signal starting from the origin 0, and towards the right side your signal is not having a value continuously, it is breaked. So we at next instant of time, that is at when time t equal to 1, we have a value of the signal as x of 1. At time t equal to 2, we have the value of the signal as x of 2. At 3, it is represented as x of 3, and so on. So here The samples are represented using a straight line followed by a bubble. This is standard representation for discrete time signals, which you need to use, and the amplitude can be represented using the positive value and negative value. So we can have the value towards the negative time axis also and positive time axis also. So one thing what you need to remember here is a discrete time signal is obtained by sampling a continuous time signal. Sampling means we will be breaking the continuous time signal at particular instance of time, and that will be represented in the discrete form. We can obtain a discrete time signal x of n from a continuous time signal by sampling process. It is called as sampling. So sampling is one process which is going to convert a continuous time signal to a discrete time form. So we will be following a theorem called as sampling theorem, wherein we will concentrate on the sampling frequency, wherein the sampling frequency fs should be greater than or equal to twice the maximum frequency of that particular signal. This is one criteria under which we are going to sample a continuous time signal to obtain a discrete time signal. Okay, so the mere replacement, what we will do is, we know that we have the signal x of t, right? So in this x of t, if I replace this variable t with n into t, this generates a discrete time signal which is nothing but x of n. So this is the process that is followed to convert a continuous time signal to a discrete time for where the independent variable time t is replaced with n into capital T, where capital T is nothing but equal to reciprocal of the sampling frequency 1 by Fs. So by taking this sampling frequency, we are breaking a continuous time signal into a different samples. Okay, so where n is nothing but the position of the sample, small n is nothing but the position of the samples, and capital N he is considered to be the total number of samples that we can have in a sequence. So this is how the sampling process is done to convert a continuous time signal to a discrete time form. So examples of discrete time signals, what we can take is DNA based sequences, the coding sequences, the digital signals, and the temperature which is recorded at a particular instant of time could be considered as an example for discrete time systems. I hope you have followed the basic concepts of continuous and discrete time signals. Okay. So please make a note of this important concept termed as sampling. This you will learn further in your communication subject also and signal processing subject also in the next semester. Now based on the type of these two inputs, we can classify the system as continuous time systems and discrete time systems. So for a continuous time system, the input will be a continuous time signal x of t, and the output is considered to be a continuous time signal y of t. So both input and output signals are continuous in nature with respect to time. So whereas if you consider the example of a discrete time system, as you can see, the input is a discrete time input, and the output will also be a discrete time output. So these type of systems are classified as discrete time systems. So based on the type of input and output what we are getting, we are basically classifying the systems as discrete time systems and continuous time systems. Now, so we have classified the signal based on their time value as continuous time and discrete time. Now similarly, based on the behavior of the signal, we can classify the signal as even and odd signals, periodic and non-periodic signals, or it is also termed as aperiodic signals, deterministic and random signals, energy and power signals. So this table gives a brief classification of the signals based on their properties. So let's take up this classification of signals in the next coming session. So today just let me give you a brief overview of the discussion what we had in today's session. So today we have discussed about basic definition of signals and systems, and few examples we have quoted for signals and systems. Along with that, we have discussed about the independent variable time, which is used to define the signal. Along with that, classification of signals, how it is made based on the time value is discussed, wherein we have discussed about the two important category of signals, that is continuous time and discrete time signals, the sampling process and the sampling criteria which is followed to sample a continuous time signal into a discrete form. So sampling is a process which is considered as a technique used to convert a continuous time signal into a discrete form. So we are converting a continuous time signal in the discrete form using the sampling process, where the variable t is replaced with the variable n into capital T, where capital T is considered as the standard time period or the fundamental time period of the signal, which is considered as reciprocal of the sampling frequency. And the condition what has to be maintained for sampling theorem is the sampling frequency fs should be greater than or equal to twice the maximum frequency content of the signal. So this has been discussed, and this is just a brief overview of the classification which will be taught to you in the next upcoming classes. Thank you one and all. Have a nice day.